Hello, welcome to the Basic Speed Test, Part 2, in which we pick a bunch of old vintage 8-bit computers from the early 1980s and we have them discover prime numbers through a prime number generation program. The speed tests are centered on the built-in basic programming languages of each computer. In Part 1, if you've watched it, we did the Commodore 64, Yamaha MSX1, and Tandy Model 102. I've received a couple comments about posting the code I'm using, so I will do that. And in addition, some comments about how to improve performance of the basic programs on the various platforms, which I agree you could easily improve. But for these tests, it's just these tests are centered around taking a program, highly portable program, and just moving it from one computer to the next with little to no modification and seeing how it performs. That might be a topic for maybe a future video, is how to increase performance per platform on these old 8-bit computers. But until that time, we're just going to proceed with this portable version of this prime number generator. And so first of all, let's talk about which computers, well, actually, let's do a refresh of what happened in Part 1. In Part 1, the Commodore 64 came out ahead, followed by the MSX, and then the Tandy 102. And the Commodore 64 actually did quite well compared to the other two platforms. So let's see how well these platforms are going to do today compared to the Commodore 64. So first of all, we have an Atari 800 XL. This came out, I believe, in 1983. It's got a MOS 6502 8-bit microprocessor in it, running at 1.78 megahertz. Today we'll be testing the internal built-in BASIC, which is Atari Basic Revision B, which fixed a few bugs from Revision A, which is the original Atari cartridge version of BASIC, but actually introduced a few of its own. That's a topic maybe of another video, though. Computer number 2 is the Commodore 128, which is a successor to the Commodore 64. This actually has a 2 megahertz, I think it's an 8502, 6502 derivative in it. And the 8502 had a memory banking in it. So the Commodore 128 had 128K of RAM. The 8502 hence, and the 6502 can only address 64K at a time. So this had some banking capabilities. It ran at 2 megahertz under certain modes. Today we're actually we're going to be running it in a 1 megahertz mode, because we're going to be running it in the Commodore 128 mode, of which there are 2 sub modes. We're running it in the mode that uses the VIC-2 chip. And the VIC-2 chip, when you're using that, and that's the chip that supports sprites in this computer, when using that chip, it forces this computer into 1 megahertz mode. So this will be a direct comparison with the Commodore 64. This has BASIC 7.0 in it. The Commodore 64 had BASIC 2.0. BASIC 7.0 is much more powerful BASIC. It's one of my favorite BASICs from this era, actually. Introduces a bunch of new commands, lots of nice things for sprites and sounds and graphics. Because of that, though, the parser or tokenizer is going to have to work harder. So I suspect this will actually end up being a little bit slower than the Commodore 64, but we shall see. And finally, what I consider to be kind of an oddball computer. Put flames in the message area for that if you like. But this is the TI-99. This is actually not an 8-bit computer. It's a 16-bit computer. It was Texas Instruments' 16-bit processor that they put in here. It was running at 3 megahertz. The reason they put it was originally scheduled to have an 8-bit processor put in when they were designing this computer, as I recall. However, the processor wasn't ready in time, so they put in a 16-bit processor. And it's the built-in BASIC in this one is interesting in that it actually leverages the graphics chip, as I recall, for some of the processing power. So it kind of gets doubly interpreted. And if you're interested, you can go look it up online and get all the nitty-gritty details. But it's kind of an interesting odd beast. But it's a great computer nonetheless. I'm glad it's in my collection. Okay, so shall we begin? My cameraman here is going to... one last thing before I forget. I could not find a way to do timing on this computer. There might be a peak or poke location. No idea. I don't know this one as well as the others. So what we're going to do is I wrote a little timer program on the 102. So when we get this one started, we'll kick off the timer. It's basically just a stopwatch program on the 102 here. And it will do the timing for us of the TI-99 code. And the Commodore 128 and the Atari 800XL, just like in part 1 of this video, will go ahead and do their own timing. Okay, so cameraman, are you ready? So the camera is going to go funky for a second while we kind of manage this. Okay, on the count of 3. All right, okay. And you'll need to hit that at the same time. Here we go. 1, 2, 3. Okay, so you can see the TI-99 is finding primes. It's crunching through there. Our Tandy 102 is doing a countdown. You can't see it. It's not displaying anything right now. The 128 here, unfortunately, I didn't realize my S-video cable that I use for my 64 doesn't work on it. So I'm just going through RF, so it's really noisy, really bad signal, but shouldn't affect the timing on this at all. So the 128 is at 137. The TI-99 is around 79. Let's see what the Atari 800XL is at right now. Let me switch inputs here. Atari is around 127, so doing pretty good. It seems to be faster than the TI-99 right now. So they're cranking. And again, we're just using the built-in Atari Basic. In part 3 of this video series, which will be the last part, I'm actually going to do some non-built-in basics on some of these platforms. Just to see if any of the third-party or other basics improve the performance. The Atari is at 167. Looks like the TI-99 is at 139. And then let's try the Commodore 128 here. Just to reference where we're at. The Commodore 128 just finished it. It's claiming 100, just over 100 seconds. So 1 minute 40 seconds to complete primes, discovering primes up to 250. Prime number 241 is the final prime. And then the TI-99 is still going at 167 right now. Switch back over to the Atari. So once again, the 128 finished at 1 minute 40 seconds. The Atari is wrapping up. It's on number 227. So at this point, between these three, the Commodore 128 is the clear winner. And when the TI-99 gets close there, we'll have to hit a key on the Tandy 102 to get a timing. Okay, the Atari finished in 164 seconds. So that's 2 minutes and 44 seconds. So quite a bit slower than the 128's built-in basic. And the TI-99 is still cranking along here. Let's see if the TI-99 is as slow as the Tandy Model 102, which currently right now is the amongst the machines I own, the record holder for slowest prime number generation. So it's going here. It's doing this weird double interpretation that I had described earlier in the video. Again, if you want details, the gross details of that, you should look it up on the web. And we're waiting here. I will say that the video output on the TI-99 is quite nice. It works well with this particular monitor. Nice and crisp. Okay, click it. Alright, so it looks like 2 minutes 44 seconds for the Atari, 1 minute 40 seconds for the Commodore 128, and oh boy, this is going to be a little tougher here to figure out. Let's see, what we're looking at here is roughly 3 minutes, 3 minutes and 50 seconds for the TI-99. So once again, Commodore 128 is fastest, followed by the Atari 800 XL, and finally followed by the TI-99. Let's take a moment here, just real quick, and I'm going to go into this multi-plan ROM I've got in this 102, and I just want to double check. So the 128 is in the lead for this set, but how does it compare to the Commodore 64? So the 128 is 1 minute 40 seconds. The Commodore 64 is just under 80 seconds, 79 seconds. So the Commodore 64 is still the fastest computer from this era for just with a non-optimized prime number discovery code. So there we have it. So Commodore 64 is still in the lead. The Tandy 102 is still in the rear. And the Commodore 128, the big brother to the 64, is a little bit slower, probably due to the fact that it has a more complicated BASIC. And there we have it. So that ends part 2. Part 3, I'm going to do some additional basics that are not built-in basics in these machines, and we'll see how they fare. Thanks for watching.